Hey guys, this is Taylor here, and today we are solving third question of weekly contest 468. Let's get started. So you are given two integer arrays, nums1 and nums2. Question is really simple. We have been given both array length as same. What we need to do? We need to transform the nums1 to nums2. Okay, we need to do some steps. We will see what those steps are. But the problem statement is simple. We need to transform nums1 to nums2. Now let's see what are the steps we can perform. Choose a subarray. We can choose a subarray, and we can remove the subarray leaving the prefix and the suffix empty. Leaving the prefix and suffix, and reinsert the removed subarray in its original order at any position in the remaining array between any two elements. At the very start or at the very end is also possible. Return the minimum number of split and merge operations needed to transform nums1 to nums2. So let's see what is given to us. I will take this example. You have been given 3, 1, 2 as nums1 and nums2 is 1, 2, 3. We need to we need to convert this array to this array, right? We can perform what we can perform. We can choose any subarray where that subarray can be of one size, that subarray can be of two size, that subarray can be anything. It can be like this, it can be all this part also. Nothing matter, no matters. So we can choose this subarray. So let me take a big example to explain the subarray part. So let's say we have 1, 2, 3, 4, 5, 6, 7, 8 just in case. So what I can do, I can choose, let's say, this subarray. If I choose, so I will remove this. So after removing, I think my subarray will look like this. 1, 2, I have removed this part. Okay, I have removed this. So 1, 2, 7, 8, this is my remaining array. This is my subarray, this is my remaining array. Now I can put this subarray, I can put this order, this numbers in any place. Either I can put here or here or here or here or here. I can't put individual elements, but whole part I can take it, and I can put it either here, either here, either here, either here, either here. This is basically the operation which is given to us, which is allowed. So let me put, let's say, here. For example, I am putting here. So my updated answer will look like something like, I am putting it here. Sorry, I am putting it here. Okay. So I will remove this. I'm putting this part. So 3, 4, 5, 6. This is updated part. Now I'm having 278 as usual. So this is the operations allowed. So I can do this operation. I can do this operation any number of times. But what I need to find, I need to find minimum number of these operations. Look, so there is no limit which subarray you can select. There is no limit how many times you can put it, keep it, no matter. But you need to find out what is the minimum number of operations that will be required to convert this nums1 to nums2. You can pick any subarray, you can put anywhere. Okay, this is allowed. So in this example, what I can do, I think, well, I can definitely pick this subarray, and I will, so remaining part will be 1 comma 2, right? I will put this subarray here in the last place. So my array will be 1, 2, 3. So I think I can get answer, right? So in one step, I can get my corrected answer. Now let's talk about the second case, example 2. So double 1, 2, 3, 4, 5, which is given to us. Double 1, 2, 3, 4, 5. Nums 2 is 5, 4, 3, 2, 1, 1. Okay, we have reversed it. 5, 4, 3, 2, 1, 1. Okay. Now, let me open this question here so I can build it. So, what is the first operation that we are doing? We are picking this subarray. We are picking this subarray, and we are putting it at position 2. So, after we are picking this subarray, let me pick it. Now, my remaining subarray will look like this, right? Now I am putting this part, this subarray in this part. Okay, so after putting it, I will get something like this: 3, 4, 1 1 2. You can see the order is maintained here. I am not disturbing the order, right? Okay, super. Now what is the next operation that I can do? um I think I can remove 411 and I can put it in the last. Okay, so I can take this array out. My updated array will be 3 2 5. I will put it here in the last. Okay, let me put it. So 3 2 5 4 1 and 1. Superb, superb. So here we had one operation, here we had two operation. Now let's check about the third operation. So optimal answer for this is 3. So what I can do, I can put the 3, I can keep, like I can take this sub array 3 2 and I can put it here. I think this will give me the correct answer. So um, 5 4 1 1 will be my remaining array after removing this sub array. Now I can put it here in this place. So 5 4 3 2 1 1, which is our given answer. 5 4 3 2 1 1. This is our given answer. So you can see that the question is like explain, like a problem statement is simple. What we can do, we can take this subarrays out and we can put it anywhere, and we need to find out minimum operations to convert this to this. Now one very important thing to note in this question is little scroll after this example. You need to scroll this and you need to read this thing. Constraints, these are very important part of this question. So you can see our array length can be from 2 to 6. Yes, 6, only 6. We can have at most of this size array, only this size array. Do you know what this thing is implying to us? We can write a absolute exponential wala solution as well, and this will work fine. If array size is only 6, our exponential solution, any recursive solution, any brute force solution, any like new solution will definitely work fine, and that is expected to us. That is expected for us to write. So we don't need to write or search for an optimal solution. Any new solution will definitely work. So I hope the problem statement and explanation is clear. Now, what helped me in solving this problem is this hints. So these hints were very clearly mentioned, and they helped me in writing the solution. So we will see how we can, what are the intuition, what are the steps to solve this problem. So let's talk about the intuition to solve this problem. So how can I solve this problem? One thing I'm really sure that the array length is only 6, right? It's only 6. So I can write definitely a brute force a naive solution. Now, we have been given something like this, 1, 2, 3, and allowed operations are I can pick up any server and I can put it anywhere. So why not to do it? Let's do it, right? So the idea to solve this problem is extreme brute force. What is this? I will try to generate all possible combinations and will check will it give me the correct answer that I required. So I think my answer like given is 312. Okay, 3 1 and 2, and my expected answer is correct converted array should be 1 2 3. Super. I will start from this array. I will put, we will see okay, what we will do exactly, but just to give you some brief intuition. So I will start from this array. I will try to generate all possible combinations. So let me try. So one thing I can do, I can pick this 3 and I can put it in this place, right? I can do it, right? Let me do it, or better. I can pick this 3. I can put it on 3 place. Let's visualize this very clearly. This is this is sorry, this is the element that I can put. Either I can put it here, either I can put it here, or I can put it here. So I think you can see clearly. I can put at the start, at the middle of this two numbers, and the end. Okay, let me try doing that. So the first thing that I can do is pick 3. Okay, pick 3. In this pick 3, I can put it here. So array will not change. That's not a problem. Okay. Next time I can put it here. So I will take this 1 2 I will put in middle. Okay, 1 3 2. Superb. Next time I will put it in last, 1 2 and 3. Superb, superb, superb. So you can see, uh, so we got our answer, right? We got our answer, but wait, it's not that simple. So many times you will not get answer. So if you have some array like this, in one step you will definitely not get answer. So what I can do, I need to explore further. This time I picked the three, right? But can I do something else as well in this array? In this array, can I do something else as well? Yes, definitely I can do. Maybe I can pick more than one element. I can pick three and one together, right? So let's do that. Let's do that. So let me again write um 3 comma 1 comma 2. Superb. This time I am picking I am picking 3 comma 1. Here I picked only 3. Here I am picking 3 comma 1 both. Okay, let's do it. Let's do it. Pick 3 comma 1 both. Okay, let's see what are the possibilities that I can have. So my remaining array will be this 2. So either I can put 3 1 in the beginning or in the last. There is nothing else, right? So there will be only two possibilities. Let me put it. So I will put 3 comma 1. So you can see order is not changed, right? 3 comma 1 I will put here. I can put 3 comma 1 here. Superb, superb, superb. Now, maybe I can take whole array, right? I can take whole array and I can put it. So that doesn't actually make sense. So whole array I can skip. Okay. Now the next thing, maybe what I can do is I have this array. So we can't stop here. We can't stop here. We need to generate all possible combinations. Maybe I can pick only this part. Definitely I can pick. Yeah, it is allowed. Okay, so remaining part will be 3 comma 2. Right, so this one I can put either here or either in middle or either in this end position. Let me do that. So I will put 1 3 2. I'll put this 3 1 2. I'll put this 3 2 1. Yes, what I did, I kept 1 year, I kept 1 year, I kept 1 year, right? Similarly, let's do for let's quickly do for 1 comma 2 as well. So for 1 comma 2, let me pick this part. My remaining array will be 3. I can put 1 comma 2 here or here. Let me do that. So 1 comma 2 comma 3. Same. Okay. 3 comma 1 comma 2. Okay. So this is another possibility. Now another thing I can have is I can only take this two. I can put it in beginning. Let's do that. Let's do that. Not a problem. So we have 3 comma 1 comma 2. What I can do is I can I can keep these two. Remaining array will be 3 comma 1. I can put 2 in the beginning, in the middle, in the last. Let me do that quickly. 2 comma 3 comma 1. Now 3 comma 2 comma 1 and 3 comma 1 comma 2. Super, super. We had explored, I think, almost all combinations for this one part. Okay, for this 312 array, right? So what I will keep track of all these arrays, everything. So this is just step one. This is just maybe you can say in one function call I need to generate all of these combinations. So let's talk about exact approach. So you got it right, how to generate all possible combinations. Let's talk about the approach. What will help me? Okay, so we have enough intuition. So approach will be, first thing, start with nums1. Start with nums1. Whatever given in nums1, we will start and we will remember this nums2. We will definitely remember this nums2, that we need to achieve this. Super. What is the second thing? I need to use a queue. Okay, a queue I need to use. I will put the 3 comma 1 comma 2 in my queue. Okay, I will put something like this in my queue. This is queue. Super. Now every time what I will do, I will remove the top element of queue. Okay, I need to remove the top element of queue. Superb. Check whether you already visited. So if you can see, if you can observe one thing, I'm getting 312 here. I'm getting 312 here. I'm getting 312 here as well. I'm getting 312 here as well. I'm getting 132. See 132. 132, 132. Here I'm not getting. Okay. So I'm getting multiple occurrences of things. 123 here. Now I'm getting 123 where 123. Okay, 123. Yeah, here also, here also. So there are a lot of numbers which I don't want to reiterate. I don't want to rework on them if I have already visited them. How can I track them? Whenever I will NQ, whenever I will DQ, whenever I will remove any element from the queue, I will put it in a visited array. Okay, visited array. That will make sure that I don't repeat this. So if I have ever run for this 312, na, I don't want to run again, because whatever I have run, the combinations are already stored in the queue, right? Already stored. So I don't want to do this thing again. Otherwise, I will keep on going on an infinite loop. So check whether you already visited that part or not. In case you haven't visited, please visit it. Visit the array. Visit the array. Okay. And next thing, generate all possible combinations. Generate all possible combination. Super. After generating all possible combinations, so this is the thing that we saw. Okay, we have to generate all these possible combinations. These are the all possible combinations we need to generate. What we need to do, I will tell you briefly. So if you have this array 3 comma 1 comma 2, I will tell you briefly again what you can do. Pick this 3, try to put it here, here, here. Super, one thing. Next time, pick this 3 1, try to put it here and here, because this is remaining array. Super. Pick this one, try to put it here, here, and here. Okay. Pick this one too, try to put it here and here in the last. Super. Pick this two, try to put it here, here, and here. Okay. So I hope this is clear. We need to pick the array. We need to start from the first part. We need to start from first part. Put it at 0th index, middle, last. Okay. Pick the one more, two sizer. In the zero size, middle, last. Pick one more size, middle, last. Okay, if you reach till end, start from the I plus 1 index, 0 plus 1 first index. Now take one size array, 0, middle, last. Okay, I hope this thing is clear. So let's try to see. After generating all possible combinations, we need to check. So after generating all possible combinations, we will just enqueue these things. We will enqueue this thing and add in queue. Okay, we need to just add things in queue. And whenever remove the top element, we need to check uh, is this equal to nums2. If this is equal to nums2, I can definitely return the count. So how can I like basically keep track of the count? So what I can do, whenever I am putting anything in queue na, I will put one more thing. Okay, what is the count of it? So let's say for example, from this 312 I have generated this 231. Now from this 231, for example, I have taken this 2. I have kept it here, let's say for example. So this is the first operation. First I kept this, I put it here in the last, right? Now the next operation, what I'm doing, I'm keeping this 2 and I'm putting in middle, right? So this is 2 operations. So how can I keep track? So when I have kept this array in my DQ, I will put a 0. When I am putting, I will do a +1. So I will keep a 1 here. Next time I will keep a 2 here. So this 2 will tell me that this is 2 operations are required to reach this array. Okay. So I hope you got it. So this is the whole approach. I think writing code is easy. You just need to understand this part. And I think this part, generate all possible combinations, is little tricky, but let's quickly see. I think we can definitely solve it. So we will take a bigger example this time to understand properly how we can generate the things. Okay, so first of all, you need to know about how to generate subarrays. Okay, so I will quickly write code for subarrays. So for I equal to 0 to n minus 1, I can go. Okay, inside this, for j equal to 0 to n minus 1, sorry, j equal to I, from j equal to I need to go till n minus 1. Okay, now I will start iterating from here. First time I will just keep this array. I will just keep this array. Okay, so let me do that. So I will in here before initializing the second loop, I will put a, let's say, pick array. Okay, pick array will be empty here. Super. Now I will add in a pick array. So pick array dot append. What I need to append? Array of, or nums of j. Super. So this is just the code to generate subarrays. So first I will get this, generate all subarrays. Okay, remember, generate all subarrays. First I will get this, then this, then this, then this. Next time I will start from this, then I will get this, I will get this, I will get this, and so on, so on, so on. All subarrays. Okay, once I have this subarray, so this pick array will tell me, okay, what is the current state of subarray, what is the current subarray I have taken. Once I got this subarray, what I need to do? Things are really simple, right? I need to find out how many elements are in left, how many elements are in right, and after that I can put it in zero place, middle, and in the last. That's it. So let's quickly see how we can do. It's really easy. No need to worry about it. It looks like complex, but if you write the code properly, it's really easy. So how can I find out whether like how many elements are in the left? So let's see. So I will initialize something like remaining array. Okay, remaining array. I will need to generate a remaining array. Super. So what I can do, I can start a k loop for k equal to 0, not 0. Wait. Oh, yes. Yeah, 4k equal to 0. I will start from 0 to, I think, I minus 1. Oh, wait. J minus 1, I think, yes. Why j? Because I am starting from j, right? I am starting from j. So I need to go till j minus 1. So in this case it will not work, but let's say I have started from here. This is my current state, right? Next time it will be this, next time it will be this. Okay, so let's say if this is my current state, so I need to append this 1 2 3 in the remaining array will look like 1 2 3 from the left side, and 6 5 6 from the right side, right? So this 4 is removed from here. So I need to put this array. So how can I do? I can do like this: k equal to j minus 1. I will put quickly remaining array dot append array of k. Okay, super. Now I need to put the right part. So how can I do that? K equal to, wait. I think I need to run this loop till I minus 1. Why till I minus 1? I will tell you. So let's say we are starting our loop from here, right? We are starting our loop from here. Our I is telling, okay, what is the start point. So we can, you can see we are initializing j with I. I will tell, okay, what is the start point. J will tell, okay, what is the window size, right? So what I can do, I can keep this equal to I minus 1. I will keep this loop as I minus 1. And next thing, I think I can initialize from j plus 1. Why j plus 1? Because after, let's say, we have considered this window, this j is telling me what is the window size. I need to start from the next element, right? So I think these things, I don't think very it's little confusing, but not complex. So from k equal to j plus 1 to n minus 1, I need to put everything in the remaining array dot append array of k. Superb. Now next thing, now what I have built here, I have built what? So let's say k, I'm keeping this 3 comma 4 3 comma 4 is my pick array, okay, and my remaining array is 1 comma 2 comma 5 comma 6. Yes. Okay, one thing you can clearly see that we can either put here in the zeroth index, okay, so this is zeroth index, this is first index, this is second index, this is third index, this is fourth index. Array size is what? Array size is 4. So I am having 0 to 4, right? So let me write a loop for that. So for k equal to 0 to length of my remaining array, length of remaining array, whatever is it is, okay. So this time it is including, okay, this time it is including because I can put in last as well. Super. Now I can definitely initialize some let's say my resultant array, something like this. Put this array, remaining array, okay. Initially I will start from here, okay. Let's see, I am having this array. Now I will try to put in the first position because k equal to 0, right? This k equal to 0 will tell me I need to put it here. Put every element, put every element here. Next time this will tell me put every element here. Next time it will tell me put every element here. Super. I will just iterate over this array and I will push it. Nothing else, nothing complex. So for element in PA, this PA, resultant array dot append dot insert dot not dot append. I don't need to insert in the last, I need to insert in a specific position. Insert at where k, where whatever k will tell, just insert at that place. What I need to insert? The element I need to insert. Superb. That's it. Now there is one thing. While iterating over this PA, I will iterate in the reverse direction. This will iterate from this first. It will iterate 4, then 3. Why this is so? Because just let me tell you. So if you have 1, 2, 5, 6. Let's say you are putting this 4 comma 3 comma 4. You are putting this 3 comma 4 in the beginning. If you let's say put this 3 first, okay. Let me put it 3 first. So you inserted 0. At 0th index, you inserted 3. So your result looks like this, right? So next time you inserted 4 in the 0th place. So 4 in the 0th place will basically reverse your this array. Reversed your this array, right? So what I did, I started from this 4. I will put this 4 here. So the array state will look like this. Then next time I will put here. So this will look like 3. So 3, 4, 1, 2, 5, 6. This will be giving me expected answer. Once I have resulted error, I can definitely store it or I can directly add it in my queue. So I hope this approach is clear to you. So just there are a couple of steps. Let's quickly go through them again. Start with nums1, whatever nums1 is given to us, with the count. So this time like this is given to me, I can initialize this with 0. Now I will remove this element from the queue and I will check whether this is equal to nums2. If this is equal to nums2, return the count, whatever count it is, return that simply, okay. Otherwise check if you have already visited. If you have already visited, no need to visit. Otherwise visit the array and generate all possible combinations. Once you have generated all these possible combinations, what you can do, you can add in queue, simple, and repeat this process. One day you will definitely get this nums2, because this is just a rearrangement. This nums2 is just a rearrangement of this array, right? Definitely you will get one day you will definitely get this nums2. And what, like, how we can directly return count, because this is a BFS approach. Where you can see we are using queue, right? We are using queue. So if the first occurrence of nums2 we are getting something, that will be the minimum number of count. That is definitely we are very sure. If you have solved the graph problem, if you write BFS, then you need to explore all possible combinations. But once if you write BFS, this is benefit of BFS. If you write BFS, then whatever, like, let's say you reach some state, let's say x comma y. So this x comma y can be reached in the minimum possible state, will be given by this BFS, right? So that thing we are sure. So let's try to write code for this. Let me put it on charging. Okay, superb. So I need to write something like generate arrays combination function. Okay, this array, this thing I will write, I will shortly write. Okay, but after that what I need to write, I think I need some q, right? So let me put it. I'm using dq here in Python, and I think I need a visited set. So visited set I need. Okay, super. Now my queue should contain the nums one, right? But with nums one, what I want a count as well. So I'm putting a zero here. Super. Now after that, what I need to do? I think my task is simple. Let's just see. So I will put this. I have kept this. Okay. What is the next thing? Remove the top element of queue. Okay. So I will write a while loop here. Okay, while loop here. Super. Now after writing this while loop, I will array comma count. I will put it like I will take it from queue, pop left. From the left of the queue, I will pop it. Super. What is the next thing I need to check whether, first of all, check whether it is nums2. So if array equal to nums2, that means I can definitely return the count that I got the answer. Super. Otherwise, if array in if tuple of array. Okay, so if you write in Python, you need to worry about this. So I'm just converting it to tuple because tuple is hashable. Tuple you can add inside, but no simple array like this you can't add in Python side. Tuple you can add inside. Okay, so that's why I'm writing tuple here. I'm just converting its data structure, and we have only 6 length size, so no need to worry about these things. So if tuple of array n visited, I can definitely continue, but like go for the next loop, right? No need to worry about this iteration. Otherwise, I need to take all arrays. All arrays equal to generate arrays combinations. Once I have all arrays combinations, I will put it in queue, right? So for new array in all arrays, q dot append new array. Simple. But with new array, what I need to append? I need to append count as well, right? So whatever count here I'm having, I will append count plus one, because I have performed one step, right? Here I have performed one step. So I will put all the arrays. So from this state, how many arrays I can get? I think I can get this array, this array, this. All this array I will put in queue. Okay, I will put in queue. Next time, if let's say I'm starting from here, I will generate all combinations, or let's say 9, 10, 12 combinations I get. So I will put everything in the queue, right? I will do like this. This is the brute force approach. That's why the constraints are very less 6, and this is an exponential solution. We can't predict the time complexity of this. It's not easy. So let's try to generate the array combination. So this is also easy. What I need to do, I need to write the first of all, I need to write the subarray generate code. For I in range, I think I can start from 0 to n minus 1. Definitely I can have a n initialized length of nums1. Okay, I think I can write n here because this is Python range function. For j in range I to n. Okay, this will exclude this n. That's why I'm writing n here. Okay, so if you write in C++, Java, and JavaScript, the code is in the description. All those languages code, so you can follow me along with that. So I think this is done. Now pick array. So this is the array that I'm picking. So I can add pick array dot append array object on nums object. Okay, nums. I think let's name it array. Easy. Super. Okay, I need to pass the array here. Super. Okay, fine. Now once I have let me write comments as well. Generate all sub arrays. Super. Now after this, cal. So after you have selected your pick array, I need to calculate the remaining array as well. Calculate remaining array. So remaining array will look like I will initialize it from 0. So first I will let's say this is my pick array 2 3. So I will take elements from here and here, right? So let's do that. For k in range 0 till I think I remaining array. Also this I is excluded, so don't no need to worry about remaining array dot append array of k. Super, super, super. Now like this is basically take left part elements ends. Okay, this is take right part elements. Super. For j in range I need to start from j plus 1 till I think n minus 1, so I will write n here. Remaining array dot append array of k. Simple. Super, super. I have remaining array, I have the pick array. Now what I need to, I need to put this pick array in different places, right? Let's see how many places I'm having. So length I'm having, what length? I think the remaining array length is length of the remaining array. I will calculate it here. Now I will write a loop for k in range. Okay, this should be k first of all. Okay, for k in range, I think 0 till remaining length plus 1 plus 1. Why plus 1 here? Because I can put it here, here, or here, or here. So if this size is 3, I need to run till 4 time, right? So that's why I'm writing. Start from 0, 1, 2, 3, 4. 0, sorry, not 1, 2, 3, 4. I mean 0, 1, 2, 3. 0, 1, 2, 3. Okay, this thing. Super, super, super. Now, um, I can initialize a result array. Result array will be a copy of remaining array. Okay, initialize. I will initialize with this. So whatever remaining array is 1 1 1 1 4 5 1 1 4 5 is my remaining array. Now this 2 3 I will put in the beginning, in middle, in middle, in middle, like that. So if I give you a correct example, double 1 2 3 4 5 is original array. 4 5, this is my pick array. I have removed this, so 1 1 4 5. I can put 2 3 here or here or here or here or here, but I will iterate over this on the reverse direction. So this is my resultant array, initial configuration. Now I will try to put this 2 3 here first. I will add in answer. I will try to put it here. I will add in answer. I will try to put here. I will add in answer. These are the different combinations that I can get, right? Now for element n what I think pick array car reverse, right? Very important. So result array dot insert at kth index. What I need to insert? Elements. Once I have inserted all the elements, I can definitely have a result or maybe answer and add it in answer dot append result array. So I'm storing all the combinations. I'm generating all combination. I'm storing all the combination. Once I have generated and stored all combinations, I think I'm pretty much done. In the last, I will just return this answer. Return answer. Okay. Looks fine. Looks fine. Let's try to run this and see whether this is a correct solution or not. Okay. I think as soon as I get, I'm returning a count here. In case I didn't get anything, I will return a -1 in the last after completing all the iterations, but definitely I will get answer from here. Let's try to run this and see. Okay, memory limit exited. Okay, very important step. I forgot to update the visited array. Visited dot add tuple of array. So if this is not present, if this is present, I will continue. I will go to the next iteration. Otherwise, I have to add in visited array, right? Very important. Let's try to see. Okay, it is working fine. One more thing. I will put here, or maybe more specifically, length of q greater than 0, so that we should not write while true. Okay, this does makes more sense. What I'm kind intended work here. Okay, so let's try to run now. Although that will not hamper anything yet, but in actual software development practices, we used to be as specific as possible, as clear as possible. Let's say tomorrow someone else is coming and writing and seeing your code, they need to update something. So that should be easy for them to write, right? So let's try to submit this and see whether that is correct or not. Video length is 40 minutes around. Okay, it is working fine. So thank you very much guys for watching this video, and in case you understood this solution, please don't forget to subscribe, because that will definitely give you a lot of motivation to create more such easy solutions. And thank you very much, and we'll meet in the next one. Thank you.
Hold me close till I get up.